$3 billion. That's what the B-29 Superfortress program cost America during World War II, making it the most expensive military project in history at that time, costing more than the Manhattan Project that developed atomic bombs, more than any other weapons program, more than some countries spent on their entire war efforts. Think about gambling $3 billion on an airplane that hadn't been built yet, on technologies that didn't exist yet, on capabilities that seemed impossible to achieve with 1940s engineering. Boeing promised to deliver a bomber that could fly higher than fighters could intercept, faster than enemies could catch, farther than any aircraft had ever flown, while carrying more bombs than anything America currently possessed. The gamble worked, and the B-29 became the weapon that brought strategic bombing directly to Japanese cities, that destroyed Japanese industry and civilian morale through conventional bombing before atomic weapons ended the war, that proved American industrial and technological superiority so completely that Japan surrendered knowing continued resistance was futile. But that success came through risking billions on unproven technology, building production facilities before testing was complete, gambling that revolutionary engineering would work when thousands of lives and the entire Pacific War strategy depended on it working perfectly. The requirements seemed impossible when Army Air Forces issued specifications in 1940 for a bomber that could reach targets 2,000 miles away while flying at 30,000 feet altitude and carrying 10,000 pounds of bombs. No aircraft in existence could meet these requirements because the engineering challenges were enormous, requiring pressurized cabins so crews could breathe at altitude without bulky oxygen equipment, requiring engines powerful enough to lift heavy bombers to heights where air was too thin for conventional aircraft, requiring remote-controlled gun turrets because manual turrets couldn't function in thin air at extreme altitudes. Boeing took the contract knowing they'd have to invent technologies that didn't exist, gambling that their engineers could solve problems that had never been solved, betting company survival on delivering an aircraft that existed only on paper and in optimistic projections. Development proceeded at unprecedented speed, with 18 months from contract award to first flight of the XB-29 prototype, an impossibly short timeline for aircraft of such complexity and revolutionary design. Boeing built production facilities and ordered materials before testing confirmed the design worked, gambling billions on the assumption that problems could be fixed during production, rather than delaying until testing proved everything functioned perfectly. This parallel development saved time but multiplied costs, because changes discovered during testing had to be incorporated into aircraft already under construction, requiring modifications to planes rolling off assembly lines while engineers were still fixing design flaws discovered in flight testing. The financial risk was enormous, and the technical risk was equally large, because failure would mean billions wasted and strategic bombing plans destroyed, leaving America without the capability to attack Japanese home islands effectively. The pressurized cabin was revolutionary for bombers because previous aircraft required crews to wear oxygen masks continuously during high-altitude missions, limiting endurance and reducing efficiency while creating physical stress that affected bombing accuracy. The B-29's pressurized cabin allowed crews to operate in shirt sleeves at altitudes where outside air was deadly, maintaining comfort and efficiency on missions lasting 12 hours or more, while flying at heights where unpressurized aircraft couldn't function. This technology required entirely new engineering approaches, including pressure bulkheads strong enough to contain cabin pressure while light enough to not exceed weight limits, seals that maintained pressure throughout the aircraft, and systems that could pump enough air to keep cabin pressure equivalent to 8,000 feet altitude while flying at 30,000 feet. Getting this right was essential because crew efficiency determined bombing effectiveness, and exhausted, oxygen-deprived crews couldn't hit targets accurately no matter how capable their aircraft. The engines represented another technological leap forward. with Wright R-3350 duplex cyclone radial engines producing 2,200 horsepower each, far more than any previous bomber engine, while maintaining reliability through missions that pushed mechanical limits. 4 of these engines powered each B-29 to speeds exceeding 350 miles per hour while carrying fuel for missions spanning thousands of miles, giving the Superfortress performance that exceeded anything Japan could deploy to intercept it. But these powerful engines also generated tremendous heat that caused persistent problems throughout development and early operations, with engine fires becoming so common that crews joked about whether their biggest threat was Japanese fighters or their own engines. Fixing these problems required extensive engineering work that delayed full operational capability while costing additional money and time that military planners hadn't anticipated when authorizing the program. The remote-controlled gun turrets eliminated manual gun positions that required gunners to operate in freezing thin air at altitude, replacing them with computerized fire control systems where gunners sat in pressurized compartments while controlling turrets through electronic sights and hydraulic systems. This was cutting-edge 1940s technology that essentially created the first combat aircraft with fly-by-wire gun systems, letting one gunner control multiple turrets simultaneously while computer systems calculated lead angles and bullet drop automatically. The engineering complexity was enormous, and the system didn't work reliably at first, requiring extensive modifications and adjustments before becoming effective in combat. But once operational, this system gave B-29's defensive firepower concentrated in positions that provided maximum coverage while keeping crews comfortable and alert throughout long missions, creating bombers that were difficult for Japanese fighters to attack successfully. The B-29 entered combat in June 1944 with operations from bases in China and India that immediately revealed operational challenges nobody had anticipated during development. The logistics of supplying bases in China required flying fuel and bombs over the Himalayas, making every combat mission dependent on dozens of supply flights that consumed more resources than the bombing raids delivered to Japanese targets. Early missions achieved limited results while suffering higher losses than expected from mechanical problems and Japanese defenses that proved more capable than intelligence had predicted, creating doubts about whether the $3 billion investment would ever justify its enormous cost. But these early operations taught lessons about tactics and maintenance that would prove essential when B-29s deployed to newly captured bases in the Marianas Islands that were close enough to reach Japanese home islands without the logistics nightmares of China operations. The Marianas bases transformed B-29 operations from marginal effectiveness to war-winning capability as Tinian, Saipan, and Guam provided airfields close enough to Tokyo that B-29s could reach Japanese cities with full bomb loads while maintaining fighter escort from Iwo Jima after Marines captured that island. Construction crews built the largest air bases in the world on these tiny Pacific islands, creating runways and facilities capable of handling hundreds of B-29s simultaneously while storing thousands of tons of bombs and millions of gallons of fuel. The scale of this construction effort was enormous, with entire islands transformed into bomber bases through American engineering and construction capability that Japan couldn't match or counter, creating infrastructure that made strategic bombing of Japan inevitable once B-29s started arriving in sufficient numbers to overwhelm Japanese air defenses. General Curtis LeMay revolutionized B-29 tactics by switching from high-altitude precision bombing to low-altitude incendiary attacks that exploited Japanese cities' vulnerability to fire while avoiding the accuracy problems that plagued bombing from extreme altitudes. His analysis showed that precision bombing wasn't working because weather over Japan obscured targets frequently, high-altitude winds threw bombs off target unpredictably, and Japanese industry was dispersed in small workshops throughout cities rather than concentrated in large factories that made good bombing targets. Low-altitude incendiary attacks solved these problems by using area bombing with incendiary bombs that started fires throughout entire urban areas, destroying not just factories but also the workers' homes and the small workshops that supplied Japanese industry. This shift from precision to area bombing was controversial because it explicitly targeted civilian areas, but LeMay argued correctly that destroying Japanese war-making capacity required destroying the entire urban industrial complex that supported it. The Tokyo firebombing on March 9 to 10, 1945 demonstrated the terrible effectiveness of LeMay's tactics when 300 B-29s dropped incendiary bombs on densely packed residential areas, creating firestorms that killed over 100,000 people in a single night. The B-29s flew at 5,000 to 7,000 feet altitude, far lower than their designed operating height, betting that Japanese defenses couldn't respond effectively to nocturnal low-altitude attacks. They were right, as anti-aircraft fire and night fighters destroyed only 14 B-29s, while the bombers created firestorms that consumed 16 square miles of Tokyo, killing more people in one night than either atomic bomb would kill later. This raid and the dozens that followed across other Japanese cities destroyed Japanese morale and industrial capacity while demonstrating that conventional bombing alone could make Japan unable to continue fighting, though at terrible cost in civilian casualties that remains controversial today. Japanese air defenses proved incapable of stopping B-29 raids effectively despite desperate attempts to intercept bombers that were destroying their cities. Fighters struggled to reach altitudes where B-29s operated during daylight precision raids, lacked the performance to catch bombers that could outrun most Japanese aircraft, suffered from fuel shortages that limited training and reduced pilot quality steadily as the war progressed. Night fighters had more success during low-altitude incendiary raids, but couldn't shoot down enough B-29s to matter strategically, with Japanese defenses destroying less than 2% of bombers on most raids, while American production replaced losses faster than Japan could inflict them. This created a death spiral where Japanese cities burned while defenders watched helplessly, knowing they couldn't stop the raids but trying anyway because surrender was culturally unacceptable despite the military situation being hopeless. The crew experience aboard B-29s during these missions was surreal as men flew through darkness watching cities burn below them, operating comfortable pressurized aircraft in shirt sleeves while tens of thousands died from fires they were creating. Pilots maintained formation discipline during bomb runs. Navigators calculated precise timing for weapons release. Bombardiers toggled incendiaries at designated points, while gunners watched for fighters that rarely appeared in sufficient numbers to matter. The missions lasted 12 to 15 hours from takeoff to landing, long enough that crews ate meals and relieved themselves using onboard facilities, while Japanese civilians died burning in streets below. That disconnect between crew comfort and human devastation below created psychological burdens that veterans carried forever, knowing they'd participated in mass killing even while understanding military necessity justified what they'd done. The bombing campaign's effectiveness is measured through Japanese industrial production statistics that show steady decline through 1945 as strategic bombing destroyed factories and disrupted transportation networks while killing workers and destroying their morale. Steel production dropped, aircraft manufacturing declined, shipbuilding slowed, all while conventional bombing created conditions that made continued resistance increasingly futile even before atomic weapons entered the equation. American analyses after the war concluded that Japan would have surrendered from conventional bombing alone if the war had continued through fall 1945, though how many more civilians would have died during those additional months of bombing remains unknown. The atomic bombs ended the war faster, but conventional B-29 raids had already broken Japanese capacity to fight effectively, making surrender inevitable regardless of whether atomic weapons were used. The atomic bomb missions represented the culmination of the B-29 program's technological and strategic purpose, when specially modified superfortresses delivered weapons that single aircraft could carry and single crews could deploy, while destroying entire cities through physics that most people didn't understand. The Enola Gay carrying Little Boy to Hiroshima on August 6, 1945, was a standard B-29 stripped of armor and guns to reduce weight, modified to carry an atomic bomb that weighed 9,000 pounds, but delivered destructive force equivalent to 15,000 tons of TNT explosive. The crew of 12 men flew a relatively routine mission by B-29 standards, taking off from Tinian in darkness and climbing to bombing altitude while navigating to target using standard procedures before releasing one bomb that killed 80,000 people instantly and doomed tens of thousands more to death from radiation poisoning. The mushroom cloud visible from miles away showed destruction on a scale that justified $3 billion spent developing bombers capable of delivering such weapons to any target in the world. 3 days later, another B-29 dropped a plutonium bomb on Nagasaki that killed 40,000 people immediately, proving the Hiroshima attack wasn't a unique weapon, but represented American capability to destroy Japanese cities at will until Japan surrendered unconditionally. The atomic bombs ended the war within days, saving millions of lives that would have been lost during an invasion of Japan, while demonstrating that American technological superiority had created weapons that made continued Japanese resistance suicidal rather than merely futile. Whether using atomic bombs was morally justified remains debated, but their military effectiveness in ending the war quickly is undeniable. The strategic bombing campaign's total impact combined conventional firebombing with atomic attacks to destroy Japanese will and capability to continue fighting. Over 60 Japanese cities were burned by conventional raids that killed hundreds of thousands of civilians, destroyed most of Japan's industrial capacity, disrupted food production and distribution, created conditions where civilians were starving while their government insisted on fighting to the last person. The atomic bombs demonstrated that America could destroy remaining cities without even risking bomber crews in conventional raids, making Japanese leadership accept that surrender was necessary to prevent total annihilation of the Japanese people. This combined conventional and atomic campaign proved the B-29's strategic value conclusively, justifying the $3 billion investment through results that ended history's largest war. The cost comparison with the Manhattan Project reveals interesting priorities, where America spent more on delivery systems than on the weapons themselves, betting that B-29s would prove valuable regardless of whether atomic bombs worked. This proved wise because B-29s conducted effective conventional strategic bombing for over a year before atomic weapons became available, destroying Japanese cities and industry through incendiary attacks that killed more people total than both atomic bombs combined. The $3 billion bought aircraft that could reach any target in the Pacific Theater, could defend themselves effectively against Japanese fighters, could operate in comfort at altitudes where crews remained fresh and alert through long missions, and could carry conventional or atomic weapons with equal effectiveness. That versatility justified the cost through combat results that other aircraft couldn't have achieved. The technological legacy of B-29 development influenced post-war aircraft design profoundly, as pressurized cabins became standard for all subsequent large aircraft. Remote-controlled turrets evolved into modern defensive systems. Powerful engines led directly to post-war designs that pushed aviation performance steadily higher and faster. The B-29 proved that enormous aircraft could be built reliably if enough money and engineering talent focused on solving problems systematically, teaching lessons about project management and technological development that influenced everything from commercial aviation to space program. Boeing's experience building B-29s positioned them perfectly to dominate post-war commercial aviation with aircraft like the 707 that used lessons learned during Superfortress development to create civilian airliners that revolutionized commercial flight. The crews who flew B-29s throughout the Pacific campaign deserve recognition for executing missions that required extraordinary endurance and courage while operating the most advanced aircraft of their era. These men weren't fighter pilots engaged in dramatic dogfights. They were bomber crews who flew long missions over hostile territory, knowing Japanese fighters or anti-aircraft fire might kill them at any moment, while mechanical problems with temperamental engines could force emergency landings at sea far from rescue. They dropped bombs that killed civilians by the thousands, understood the moral weight of what they were doing, justified it through military necessity and belief that ending the war quickly saved more lives than their bombing cost. Whether that calculation was correct remains debated, but their courage in executing orders under dangerous conditions is unquestionable. The Japanese perspective on B-29 raids was terror and helplessness as civilians watched their cities burn while knowing their government couldn't protect them and wouldn't surrender despite obvious defeat. American bombers flew overhead with impunity, dropping incendiaries that created firestorms impossible to fight, killing civilians who'd done nothing except have the misfortune to live in cities that American military planners targeted for destruction. Japanese air defenses tried desperately to stop the raids but lacked the aircraft, the fuel, the pilots, and the technology to prevent American bombers from destroying cities systematically. This helplessness created demoralization that contributed to Japanese surrender by making clear that continued resistance meant watching American bombers destroy Japan piece by piece until nothing remained. The moral questions surrounding strategic bombing remain relevant today as we debate whether deliberately targeting civilian areas is ever justified militarily. The B-29 campaign killed hundreds of thousands of Japanese civilians through conventional bombing and tens of thousands more through atomic attacks, raising questions about proportionality and discrimination that international law now addresses through treaties that the B-29 campaign helped inspire. American defenders argue that strategic bombing shortened the war and saved lives overall by preventing an invasion that would have killed millions, while critics argue that targeting civilians is never justified regardless of military necessity. Both perspectives have validity, and the debate continues precisely because the B-29 campaign demonstrated both the military effectiveness and the moral cost of strategic bombing taken to its extreme. The production achievement of building nearly 4,000 B-29s during wartime represents American industrial capability at its peak, when factories produced complex aircraft faster than enemies could destroy them. The $3 billion program employed hundreds of thousands of workers across multiple production facilities that built components shipped nationwide for final assembly, creating supply chains that demonstrated American manufacturing superiority over both Germany and Japan. This industrial capacity won the war as surely as military victories did, because outproducing enemies meant America could absorb losses while maintaining strength, could replace destroyed equipment faster than enemies could destroy it, could sustain campaigns that broke enemy capacity to fight regardless of their soldiers' courage or determination.
If stories like this matter to you, if understanding how technology and industry win wars matters, if recognizing the human cost of strategic bombing matters, subscribe to the Foxhole Chronicles. We tell forgotten stories every week about weapons that changed everything, about crews who flew impossible missions, about the moral complexities of total war that killed civilians to save soldiers. The B-29 story is one among many more coming, and we need you with us to remember not just the triumph, but the tragedy, not just the victory, but the cost, not just the technology, but the humanity. Subscribe and stay with us through all the stories still to tell. The final assessment of the B-29 program shows that $3 billion bought the weapon that ended World War II by bringing strategic bombing directly to Japanese cities in ways that made continued resistance suicidal. Whether through conventional firebombing that killed hundreds of thousands or atomic bombs that killed tens of thousands more, B-29s demonstrated American capability to destroy Japan systematically until surrender became the only rational choice available to Japanese leaders. The technological achievement of building aircraft that could fly higher, farther, and faster than anything opponents fielded proved decisive in Pacific victory, validating the enormous financial gamble through combat results that justified every dollar spent. The moral cost of that victory in civilian deaths remains controversial, but the military effectiveness is undeniable, and the technological legacy continues influencing aviation today.
The comparison between B-29 costs and Manhattan Project costs illuminates American priorities, where building delivery systems received more funding than developing the weapons themselves, showing that military planners understood that revolutionary weapons need revolutionary delivery systems to achieve strategic impact. This proved wise because B-29s conducted effective conventional bombing long before atomic weapons existed, destroying Japanese industry and morale through incendiary attacks that demonstrated bomber effectiveness regardless of what bombs they carried. The $3 billion investment bought versatility and capability that worked with conventional or atomic weapons equally well, creating strategic bombing force that could destroy any target anywhere in the Pacific theater through either massive conventional raids or single atomic strikes. The crews who survived the war carried memories of burning cities and dead civilians alongside pride in serving aboard the most advanced aircraft of their generation. They'd flown missions that helped end the war, dropped bombs that killed enemies and civilians alike, operated in combat zones where any mission could be their last, witnessed devastation from above that ground troops never saw. Some struggled with moral questions about strategic bombing's civilian costs, while others justified everything through military necessity and belief that shortening the war saved more lives than it cost. All agreed the B-29 was an extraordinary aircraft that pushed technological boundaries while delivering military results that ended history's most destructive war, though whether those results justified the methods remains debated among historians and ethicists today. This is the B-29 Superfortress, the $3 billion bomber that cost more than the atomic bomb project it delivered. The aircraft that brought strategic bombing to Japanese cities through conventional firebombing and atomic strikes that ended World War II. Revolutionary technology, including pressurized cabins and remote gun turrets and powerful engines, enabled operations that previous bombers couldn't perform, flying higher and farther and faster than Japanese defenses could counter effectively. Nearly 4,000 built through American industrial might that outproduced enemies regardless of their determination to resist, creating bomber force that destroyed Japanese cities systematically until surrender became inevitable. The moral questions about targeting civilians remain relevant today, but the military effectiveness is undeniable, and the technological legacy continues influencing how we build aircraft that must operate in hostile environments while protecting crews who risk their lives executing missions. The atomic missions represented the climax of strategic bombing evolution, from precision attacks on industrial targets to area bombing of cities to single aircraft destroying entire urban areas through physics that made conventional bombing obsolete. The Enola Gay and Bockscar dropping atomic bombs on Hiroshima and Nagasaki demonstrated that technology had created weapons so destructive that warfare itself would need to change, that future conflicts couldn't use atomic weapons freely without risking human extinction, that the B-29 program's success in creating effective delivery systems had helped create weapons that made total war too dangerous to fight. This paradox, where developing better weapons makes war less likely, defines the nuclear age that B-29s helped create, showing that military technology can advance beyond the point where using it remains rational, regardless of political objectives. The production lines that built B-29s demonstrated American industrial capacity operating at peak efficiency when multiple factories produced components that fit together perfectly despite being manufactured thousands of miles apart. This manufacturing achievement represented a triumph of standardization and quality control that Germany and Japan couldn't match, showing that American industry could produce complex weapons at scale while maintaining quality that made every aircraft combat capable from the day it rolled off assembly lines. The $3 billion paid for factories and workers and materials and expertise that created bomber force capable of strategic operations that previous generations thought impossible, proving that industrial capacity determines military outcomes as surely as battlefield courage does. The legacy lives in modern strategic bombers like the B-52 that trace their lineage directly to B-29 innovations, using pressurized cabins and advanced engines and sophisticated systems to deliver weapons to any target worldwide. The technologies pioneered on the Superfortress became standard features that all subsequent large aircraft incorporated, proving that revolutionary engineering creates capabilities that persist long after the aircraft themselves become obsolete. Commercial aviation benefited equally from B-29 development as Boeing used lessons learned to create passenger aircraft that made intercontinental flight routine rather than adventurous, transforming commercial aviation through technologies originally developed for military bombers. That civilian benefit helps justify the $3 billion military investment by showing that advancing aviation technology creates benefits extending far beyond original military purposes. This is the final truth of the B-29 Superfortress program that gambled $3 billion on unproven technology and won that gamble through aircraft that ended World War II while revolutionizing aviation. The cost exceeded any other weapons program, including atomic bomb development, justified through combat results that demonstrated technological superiority wins wars when combined with industrial capacity to mass-produce revolutionary designs. The conventional bombing campaign killed hundreds of thousands through incendiary raids that destroyed Japanese cities systematically, while atomic missions killed tens of thousands more while demonstrating that continued resistance was suicidal. The moral questions about civilian targeting remain unresolved, but the military effectiveness is undeniable, and the technological legacy continues influencing how we design aircraft and conduct warfare in the nuclear age that B-29s helped create. The final accounting shows that $3 billion bought victory in the Pacific through strategic bombing that destroyed Japanese capacity and will to fight, proving that investing in revolutionary technology creates military advantages that determine war outcomes. The B-29 wasn't just an aircraft, but a complete weapons system that integrated revolutionary technologies into platforms that could execute missions impossible for previous generations of bombers, flying higher and farther and faster while protecting crews through engineering innovations that became standard features for all subsequent aircraft. Whether the civilian costs justify the military benefits remains debated, but the fact that B-29s ended the world's most destructive war is undeniable. That achievement validates the $3 billion gamble and honors the crews who flew these missions despite understanding the moral weight of what they were doing, because sometimes ending a war quickly through terrible means saves more lives than fighting it longer through conventional methods.